Hi, everyone. As Steve mentioned, my name is Julie Q, and I work on the Go team as a software engineer in New York City. And today I want to talk about a problem that most of us have probably come across before, which is that at some point, we all want to use some functionality that we're pretty sure somebody else has already built before. And in cases like this, we might not want to rebuild that behavior from scratch, but rather what we want to do is find a third-party package to implement it for us. And there's a lot of different ways that we can go about figuring out which Go package we should use. But today I want to share with you some of the tools and strategies that I've learned throughout my time working with Go, and as well as some of the new tools that the Go team is working on to make this process for discovering and evaluating third-party packages better for Go users. So a little bit about what I do on the Go team. I'm currently working on the team that is
All right, I'll just talk loudly until it comes on. I was warned this might happen. Actually, I was warned this is going to happen. So I'm just going to get up here and talk until it stops happening. And that is my job. Cass just volunteered to do some karaoke. Oh no, I'm all right. I need music. All right. So, what is the coolest thing you've done in Tenerife so far? What? Scuba diving. That was pretty fun. I was there. I also did that. Anyone else? Okay, who here just arrived this morning and hasn't done anything yet? Okay, so only one of you. So the rest of you, what is the coolest thing you've done so far in Tenerife? Walking on a volcano? Really? And you made it back alive? Oh, it's not active. Okay. All right. All right. All right. Anyone else?
Wait, I have a question.
Yeah.
Does anyone have a USB-C to HDMI adapter?
There we go.
HDMI? Yes.
All right. We got one right here too. We got it. Look at these nerds coming prepared. It's like no other audience in the world would multiple people be like, yes, we do. Thank you very much. We will bring it up. We have like 6 backups just in case. All right. Anyone else do something cool? Memorable? Awesome? Forgettable? You were fixing what?
Can you open it? Could try this one.
Oh. All right.
Perfect.
We good?
Yes.
All right, we're good.
Thank you to whoever brought that up. Woo! And we have a backup one in case anything goes wrong again. So back to what I do on the Go team. So I'm currently on the team that's working on building out Go modules. And specifically, I'm leading the project to build a site that Go developers can use to discover and evaluate packages and have the information that they need to learn whether or not they want to integrate the packages that they choose into their code base. And in the course of my time working with Go, I've come across a lot of cases where I want to consider using a third-party package myself. And in times like this, I'm often asking the question, how do I decide which package to use? So to see what this might look like in practice, let's talk about something that we might want to build and how I could go about finding third-party packages to do what I need. So to take an example from my personal life, something that I've always loved to do is cook. And back in the early 2000s, I would keep all of my recipes in a recipe book like this. I would handwrite the recipes that I like into this book, maybe with some helpful notes based off of my experience making it. But over the years, my recipe collection has grown. And then it started to look like this. And then this. and this. And now what ends up happening is that whenever I actually find time to sit down and decide that I want to cook something, I'll remember that there's some recipe somewhere that I've been meaning to try. And then for about half an hour, this will be me. So because my collection these days is such a mess, what I really want to be able to have is a place where I can keep track of all the recipes that I like, just like the good old days with my recipe book. And since I'm an engineer, I'm going to build myself a web app. So what I want is to be able to go to a screen like this with links to all of my favorite recipes. I want to have some UI where I can write my recipes in Markdown and then see them displayed in HTML. I want to be able to store photos, so then I can have pages like this with really pretty pictures. And when I think about all the features that I might want to have on my site, you can imagine that I might not want to write all of these things from scratch. And it's also possible that someone else has already written a package to do some of the things that I need. So let's talk about how I might go about finding one of the packages that I need on this list, which is a Markdown parser. Whenever I need a package to do something, the first place I would check is the Go standard library or any of the other packages that's owned by the Go team. I know that these are going to be heavily maintained and widely used. But the Go standard library also can't solve every problem. And in this case, it doesn't have a Markdown parser. But thankfully, there are millions of Go developers in our community, just like Cass mentioned, and many of them are willing to open source and share their packages. So today, I want to talk to you about how we can go about finding the third-party packages that we need. We'll start by talking about the discovery phase, or the process to actually go about finding these packages. Once we find the packages, we'll talk about signals that you can use to evaluate third-party packages. And lastly, we'll talk about how to go about maintaining them in the long run. So let's get started with the first part of the journey, which is discovery. In the discovery phase, what we're trying to figure out is what already exists in the community that does what I need. So one thing, if I really needed to find a Markdown parser, what I could do is I could put out a tweet and ask my friends what they're using. And if I'm really lucky, I might also get back a really helpful response. So one of the great things about crowdsourcing for answers is that if a developer that I trust is suggesting something for me to use, then it's a really high signal that it's going to be something usable. If nobody responded to my questions, something else I could try is to summon it. And if that doesn't work, then I'll probably have to resort to searching for it myself. And a lot of times I'll find that I can find a lot of results. But oftentimes the issue is really that I have way too many packages. So how do I decide which one to use? So let's talk about some of the evaluation signals that you can use to figure out which package is best for you. Of the packages that I found, I want to figure out, are they going to be able to help me solve my problem? And not only are they going to solve my problem today, but is it going to solve it in production, and is it going to continue solving it a few months or a few years from now? It can be kind of hard to get a definitive answer to these questions, but there are a lot of heuristics that we can use. So one of the first signals that we could look at is whether or not the license for the package that I'm evaluating is acceptable for my intended use. Just because you see a project on GitHub, it doesn't mean that it necessarily has a proper license or even a license at all. So in my case, when I first started this project, maybe I was just using it to set it up for fun and keep track of my own recipes. But over time, I might also find that a lot of other people really like my recipes. And so maybe my website will take off into something I can turn into a small business. So I might put up a few ads and start using my recipe website to make money. If I'm now using packages that have licenses that don't allow for commercial use, it means that legally I'm not actually allowed to use this code, and I could get in trouble for doing so. If the license is acceptable for what I want to use the code for, then one of the next signals that I'll often look into is the package popularity. There are a lot of metrics that we can use to measure how popular a package is, from its download statistics to the number of stars or contributors and watchers on GitHub. But a lot of this data can also just be noise. For example, if a project has a lot of stars, it doesn't necessarily mean that the quality of the package is great, but maybe just a lot of people recently learned about it because it was posted on Hacker News. So when we look at popularity, what we're really using it as a heuristic for is, have other people already used this package, and are they evaluating it favorably? So that's why the number of other packages that depend on the package that I'm looking at is probably one of the most useful signals from this list. If there are a lot of other people using the package, then it's a good sign that the code works well enough and that bugs are likely going to be detected faster. So at this point, I know I'm allowed to use this code. I know a lot of other people are using it. So something I might want to look at is the actual quality of the code itself. I want to be able to understand the state of the code today, and when I'm evaluating code quality, what I'm trying to figure out is this something that I would actually want to pull into my own code base? So let's take a look at another package that I need from my list, which is some sort of API to be able to store and access images for my site. When I first start using a package, I want to know, is it clear to me how this package should be used? High-quality packages will often have proper documentation, particularly if the feature set is really large. And when I look at the package's documentation, I want to see that there's package-level documentation that describes the overall feature set. I want to see that there are examples that make it clear how to actually use the package. And in looking at the specific functions, I want to see that all of the exported types and functions are being documented well. So this means having information on what it's doing, what's going to happen with the parameters, and what kind of errors I can expect to be returned. It should be clear from the documentation alone how to go about using the package. Next, I want to get a sense of the tests. So tests help to establish that the code's basic functionality is correct and that regressions would be caught as things change in the future. So a useful check for this is just open up the package and see if there are any test files. If not, it's pretty unlikely there are any tests. It's also very useful to know if the tests are actually passing. So a lot of repositories will put a badge in their README and let you indicate the status of the build. You can also download the package and run the test to make sure that they pass. And lastly, I want to look at the code itself and make sure that it looks like clear, idiomatic Go code. Seeing that the code follows Go conventions is important because you might have to debug this code later on. And if it's completely like anything you've ever seen before, you might be in for a late night. So open up a few files and scan for the general shape and style of the code. And ask yourself, does this look like clear, readable Go code? Does it look like the code has been Go formatted? Are you seeing a lot of places where the code is panicking or exiting unexpectedly, or are errors being returned in such a way that you can handle and log in your own project? And when you look at functions, are they returning concrete types that are understandable, or are there a lot of layers of abstraction? Whether or not the source code follows Go conventions can give you a sense of its overall quality. And even if the state of the code is great today, we want to get a sense of how we can expect this code to change over time. So this is particularly important if the code is complicated and likely to have bugs or security vulnerabilities, such as the API client that I need to access images for my site. So what I want to know around Upkeep is, what is the maintainer activity for this package? One of the useful signals to look at is just who the maintainers actually are. If the maintainers have a history of shipping great packages, or the package is being maintained by a large group of people, maybe being paid, then the package is likely to have steady improvements and upkeep. It's also useful to look at the project's commit history to see how long the code has actually been maintained for, especially if it's a project that requires active development. So to figure out if that's the case, you can look at the project's issue tracker and check out the status of existing bugs. Are there many bugs open, and how long have they been open for? Are issues being promptly fixed? And even more importantly, if you decide to submit a fix to this project, you want to know that your hard work is going to get merged. Or is this going to be one of those cases where, you're just sitting there for days and days, having to maintain your own fork, and really wondering, am I just talking to myself here? Knowing that my bugs are going to get fixed, though, is just one part of evaluating maintenance. I also want to know that when these fixes are released, that I can upgrade my packages and I'm not going to see any breaking changes. And then in general, the API is going to be stable over time. After all, when you decide on a package, it's a long-term commitment. So you care about what's going to happen to this third-party package in the future, and you don't want to commit to a package that has a history of breaking its users. So when I look at a third-party Go package, how do I know what sort of compatibility promises it's actually making to me? Well, with the introduction of modules into the Go ecosystem, there are some conventions that you can start to use. For those of you who are not familiar with modules, a module is a set of packages that are versioned together. These packages usually have some sort of properties that depend on each other, and modules provide us with a way of grouping packages into a unit so that we can know that they can evolve together. So as an example, a module for this Blob API client that I'm using might look like this. In my code, I might be using a package called the GCS Blob package, but this package could be part of a bigger module, which also contains packages for S3 Blob or Azure Blob, and they might all depend on code in some top-level Blob directory. So from the provider's point of view, this collection of packages should really be evolving together as a unit. And why this matters to you for evaluating API stability is because modules now formalize certain conventions that signal what compatibility promises a third-party package is making to you. One of these conventions is the import compatibility rule, which states the following about stable packages. So if there's an old package and a new package and they have the same import path, then the new package has to be backwards compatible with the old package. So if I'm upgrading my third-party package and its import path hasn't changed, then I should expect for it to be backwards compatible with any code that I've already written. The second is that modules follow the rules of semantic versioning. So this means that if I'm using a blob at version 1.1.0, and I want to upgrade it so I can use a new feature at version 1.2.3, at minimum, I shouldn't have to worry that my code's going to break because someone removed an exported function that I was using. But also, I shouldn't expect any of the behaviors for existing functions that I'm using to change either. But on the other hand, if I see a package of a major version of 0, it means that it's still being developed in the experimental mode, and so I can expect there to be breaking changes in the future. And lastly, when you're looking at your third-party package, you want to know what it's depending on itself. From your point of view, this might be the only package that you care about. But that package is bringing on a lot of other stuff into your code base because of its own transitive imports. So you might want to be able to see how many imports it has and then evaluate each of its imports using the strategies that we just discussed. We want to know, does the dependency that I'm looking at have dependable dependencies itself? Otherwise, we could find ourselves in a situation on a late Friday night when we have to deploy a bug fix, only to be staring at errors in a build log, trying to figure out what went wrong. And maybe one of the reasons is that one of your indirect dependencies got deleted, and no one knows where the code has gone. This also might be why we shouldn't deploy on a Friday night. So we've looked at several signal todays for evaluating packages. And we started by asking, how do I decide which package to use? But it's also possible that at the end of your evaluation phase, you're also asking the question, should I be using a third-party package at all? Using a dependency always comes at a cost, and the cost of adding a dependency for really trivial functions is likely higher than just writing the code yourself. For example, say I wanted to add notes in my recipes for myself, and I want them to be formatted in such a way that they're aligned to the right side of the page. And since I can't do that with Markdown by default, maybe in my search, I found a great package called Markdown Align Right. And what it claims to do is align my text in these tags to the right side of the page. But when I look at the code, what I realize is that all it is a function called pad left, which pads a bunch of white space characters to the left side of a string. And this would be the output at that function. So in this case, the cost of using a dependency could be higher than just re-implementing it myself. After all, even a single function could introduce problems. What if the user deletes it off the internet? And of course, in this case, I could also use a CSS class to solve this problem. There are definitely going to be times, though, in my evaluation process that leads me to wanting to commit to a package. And in that case, I'm going to have to think about how I'm going to maintain this for the long run. A package might be working great for me today, but what work do I need to do to make sure that it continues working a few months or a few years from now? After all, my recipe business is doing great, so maintaining this website means that I'm going to have to make sure that I'm maintaining the third-party packages I've committed to. The most important step in this is just staying up to date. We want to know that when new versions are being released, when they're being released. So you can do things like follow the mailing list or the Twitter handle of third-party packages that you subscribe to, if that's something that they have. GitHub also now lets you watch your repository specifically for new releases. In addition to knowing that there are new releases, you also want to know what's actually changing. So it's useful to read the release notes, reevaluate the code, and run all your tests to make sure that there are no regressions. And lastly, as you continue to use a package and commit to it in the long term, you might consider contributing to the project yourself. This can be doing things like reporting bugs as you come across them. It can be contributing bug fixes, documentation changes, or just adding examples and tests. And if this package is being sponsored by a group of independent developers, maybe in their free time, you can also choose to donate to it financially. So we've discussed a lot of strategies and ways to discover packages, the signals you can use to evaluate them, and how to maintain dependencies in the long term. So hopefully you've learned something new and feel like the next time you're searching for a third-party package, you have some of the tools that you need to figure out which one is right for you. But when you actually sit down and look at all the third-party packages that come up in your search results and go through their distinct documentation and run their own analyzers, you might also wind up finding that your computer screen will look like this. And at this point, rather than feeling really empowered with all the information that you've been given, you might actually be thinking that it's all just too much. And that's totally understandable, because really the way that we discover and evaluate packages today is pretty overwhelming. So how can we make this process better? Well, the good news is that there are a lot of tools that exist in the Go community today. For viewing documentation, you can easily see the documentation of any package at godoc.org. You can see information on its imports. You can use the go command to evaluate test coverage. And there are plenty of tools available for checking code quality. So for example, Go report card will run static analyzers like GoFumt and GoVet. And alternatively, you could download a package and run static check to look for code correctness, simplicity, and style. And while as a Go community, we've come pretty far in developing tools for evaluating third-party packages, of the signals that we've talked about today, there's still a really long way that we could go. And so on the Go team, we've been asking ourselves, how can we make this process even better? And I mentioned at the beginning of the talk that we're working on a site to build for Go developers to be able to more easily discover and evaluate packages. It's something that we're just getting started with, but I want to share with you some of our mocks and what we've been brainstorming. So with the introduction of modules and version packages, we want Go users to be able to do things like view documentation for any version of a package. When you're looking at a package, we also want you to be able to see what other packages are part of that module, along with the package's release history, what it's importing and information for each of its imports, and what other packages are using this third-party package. So these mocks are just to show you the foundation of what we're starting to build. But in the long run, the goal for this site is to provide a more streamlined discovery and evaluation process. So that way, when I actually sit down and decide to go and build my recipe website, and I need a markdown parser, I won't be spending my time searching for options and looking through all of the results on Google search. I won't have a computer screen that winds up looking like this, or having my day look like this. But rather, given all the signals that I could be using to evaluate a package, I'll have some way of bucketing them into a top-level score that's more comprehensible to me. And for each of the third-party packages that I'm evaluating, I'll have access to this information so that when I do go typing into a search bar looking for a markdown parser, I'll see this list of results and be able to trust that the information that I need to find the package that I want is there. So we're still working on how to get there, and we want the Go community to be part of this project. It's something that we're building now and eventually planning to open source. So we want to hear from you on how we can make the package evaluation experience a better experience for Go users. So if you have any suggestions, I'll be here for the rest of the conference, and please come talk to me or reach out to me on Twitter. Thanks.